Hi students, welcome to Sai Niketan online classes. In last class we have completed chemical properties of amines and preparation method of diazonium salt, that is a diazotization method. Next topic is physical properties. Of benzene diazonium salts. Here this benzene diazonium chloride N2Cl benzene diazonium chloride is a colorless compound and it is a crystalline solid. This is a colorless compound and it is a crystalline compound. Hence, benzene diazonium chloride is a colorless crystalline solid. And here, this benzene diazonium chloride is soluble in water. And it is stable in cold water. And it reacts with warm water. Thus, it is generally soluble in water and stable in cold water. That means if you take hot water, it reacts. Okay. And if you take benzene diazonium fluoroborate, that is C6H5N2BF4. This is the benzene diazonium fluoroborate. It is insoluble in water. And it is stable. At room temperature. It is stable at room temperature. This point is important, objective purpose. Which of the following is more stable at room temperature? They will give benzene diazonium chloride, benzene diazonium fluoroborate, okay, both or none of them. So, what is the answer? Here, benzene diazonium fluoroborate is the more stable at room temperature. Okay. So, these are the physical properties of some benzene diazonium salts. Next topic, chemical properties. Here, reactions of benzene diazonium chloride can be classified into two types. And this benzene diazonium chloride has a high reactivity due to the presence of a very good leaving group. That is a diazo group. Thus here this diazo group, if you take ArN2Cl, here nothing but phenyl group C6H5. So in this one, this diazo group is best living group, easily can remove from this compound. Thus it has very high reactivity, okay, and this is removed as N2 gas. Then another atom can be substituted in the place of this N2. Thus these compounds have very high reactivity. Thus this benzene diazonic chloride can undergo very fastly in reactions, okay. These reactions are two types. How many types? Two type of reactions we have. They are, first one is reactions involving displacement of diazo group. Second type is reactions involving retention of diazo group. Here reactions involving a displacement of diazo group, these reactions also known as replacement reactions. And reactions involving retention of diazo group, these reactions also known as coupling reactions. Here reactions involving a displacement of diazo group means these are the reactions in which here diazo group can be completely replaced by any monovalent atom or group. Such reactions are called as reactions involving displacement of diazo group. Means here if you take benzene diazonium chloride N2Cl, then in this one this group is completely replaced by another any monovalent atom or group also, monovalent atom or monovalent group, and this N2 is removed as N2 gas, that N2 is removed as N2 gas. Such reactions are called as here replacement reactions, okay, because replacement takes place now, thus these are called as replacement reactions. Which replacement takes place? Here diazo group, hence here these reactions are called as reactions involving displacement of diazo group, okay. Second type of reactions are reactions involving retention of diazo group, means here these are the reactions in which both nitrogen atoms are retained. Means N2 group retained and X minus is replaced. Such reactions are called as coupling reactions or reactions involving a retention of diazo group, okay. In these reactions if you take benzene diazonium chloride, then here N2Cl, in this one here diazo group is present, won't replace, only this Cl is replaced. Such reactions are called as here coupling reactions. There is also known as reactions involving retention of diazo group, okay. These are the two type of reactions of benzene diazonium chloride, okay. Again detailedly we have to discuss reactions involving displacement of diazo and retention of diazo, okay. That is replacement reactions and coupling reactions, okay, we have to discuss. Next topic is replacement reactions, means reactions involving displacement of diazo group. reactions involving displacement of diazo group. These are also known as replacement reactions. Now, what is the definition? The reactions in which diazo group that is N2X group is replaced by monovalent atom or group. Such reactions are called as replacement reactions. In this one, first one is here replacement of diazo group. By halide ion or cyanide ion. Then take here benzene diazonium chloride into Cl. Then here if you take benzene diazonium chloride which is react with cuprous chloride and HCl, then we get chlorobenzene. This benzene diazonium chloride is react with cuprous bromide and HBr, then we get here bromobenzene, and it is react with potassium cyanide in the presence of CuCN, then we get here cyanobenzene. Okay, here this diazo group is removed as N2 gas. Thus in every reaction N2 gas is formed as a byproduct. Okay, these reactions are called as, what is the name of these reactions? Here Sandmeyer reaction, hence it is called as a Sandmeyer reaction. What is that? Sandmeyer reaction. So Sandmeyer reaction already you know very well, in it came in chapter haloalkanes and haloarenes. Okay, thus benzene diazonium chloride is react with HCl in the presence of Cu2Cl2 or CuCl, both are same only. Then we get chlorobenzene if it is react with HBr in the presence of Cu2Br2 or CuBr to form bromobenzene. Otherwise benzene diazonium chloride is react with potassium cyanide in the presence of CuCN, then we get cyanobenzene. So these reactions are called as Sandmeyer reactions. Okay, and another one is there, that is the Guttman reaction. Guttman reaction means here benzene diazonium chloride is react with HCl in the presence of copper, then we get here chlorobenzene. Similarly it is react with HBr in the presence of copper, then we get bromobenzene. Okay, here byproduct is N2 gas, here also byproduct is N2 gas. Okay, these reactions are called as a Guttman reaction. If you used here CuCl or Cu2Cl2 or Cu2Br2 HCl then these reactions are called as Sandmeyer reactions. But if you use HCl in the presence of copper, HBr in the presence of copper, then the products are same only, chlorobenzene, bromobenzene, but this reaction is called as a Guttman reaction. If you used copper, that is called as Guttman. If you used Cu2Cl2 or Cu2Br2 or CuCl, CuBr, that is the Sandmeyer reaction. Okay. Thus in these all reactions, this N2Cl is replaced by halide ion and here cyanide ion. Okay. Thus these are the displacement reactions of diazo group by halide ion or cyanide ion. Okay. Next one. Replacement of diazo group by iodide ion. Here benzene diazonium chloride is react with potassium iodide. Then here potassium, here Cl removed as KCl, and this diazo group is removed as N2 gas, and here we get iodobenzene by the attacking of this iodide on this benzene ring. Thus we get here iodobenzene. Thus here this N2Cl is replaced by iodide ion, thus we get iodobenzene. Thus we can prepare the iodobenzene from benzene diazonium chloride. Next reaction, replacement of diazo group by fluoride ion or nitro group. In these reactions, take benzene diazonium chloride. This is the benzene diazonium chloride, which is react with HBF4. It is the fluoroboric acid. What is this? Fluoroboric acid. Then what happened here? Here H, here Cl, removed as HCl. Then after dissociating H plus and BF4 minus, then BF4 minus is attacked on this diazo group. Thus we get N2BF4. What is the name of this one? This is the benzene. N2 means diazonium. Next fluoroborate. This is the benzene diazonium chloride is react with the fluoroboric acid. Then we get benzene diazonium fluoroborate. Now here if you heated this compound directly on heating, what happened here? N2 group is removed as N2 gas and BF3 molecule removed, then one more fluorine is there, that is attacked on this one. Thus here we get fluorobenzene and N2 gas formed and BF3 molecule produced. Okay, BF3 is removed, N2 gas is removed, then fluorine is attacked on this benzene. Thus we get fluorobenzene. What is the name? This is the fluorobenzene. Okay. Otherwise, take same compound, that is benzene diazonium fluoroborate. Then it is heating with NaNO2, sodium nitrite, in the presence of copper. This one. Then what happened here? Na plus, here BF4 minus. Both are combined together, removed as NaBF4, sodium fluoroborate. NaBF4, sodium fluoroborate. And here diazonium group is removed as En2 gas. Diazonium group is removed as En2 gas. Then here what is there? NO2 minus is there. This NO2 minus is attacked on benzene. Thus here we get nitrobenzene. What is this? This is the nitrobenzene. Thus here when benzene diazonium chloride is reacted with fluoroboric acid, we get benzene diazonium fluoroborate. On heating, we get fluorobenzene. But heating with sodium nitrite in the presence of copper, then we get nitrobenzene. Okay. Thus, in these reactions, this N2Cl is replaced by fluoride ion and nitro group. Okay. Next one. Replacement of diazo group by here hydroxyl group. Hydroxyl group means OH group. OH is called as hydroxyl group. Okay. Now take a benzene diazonium chloride. N2Cl is benzene diazonium chloride, which is heated with water. Water means H2O. On heating up to 283 Kelvin. Okay. Then here H, here Cl, removed as HCl. And here diazo group is removed as N2 gas. And then what is the remaining one? OH. OH group is attacked on this benzene nucleus. Hence we get phenol. Thus benzene diazonium chloride is heated with water at 283 Kelvin. Then we get phenol. In this one, this N2Cl is replaced by which group? Hydroxyl group. Okay, thus we can prepare the phenol from benzene diazonium chloride. Okay. Next property. This diazonium group can be replaced by hydrogen also. Replacement by hydrogen H. Then take benzene diazonium chloride, N2Cl, which is react with H3PO2. H3PO2 is the hypophosphorus acid. Okay. Or it is also called as a phosphonic acid. In aqueous medium, in which? In aqueous medium, then here this oxygen is combined with this hypophosphorus acid. What is this? This is the hypophosphorus acid, or another name is phosphonic acid. Is combined with oxygen. That means it become as here H3PO3. This oxygen is combined with this molecule, okay, phosphoric acid. Then here hydrogen, here Cl, removed as HCl. Then this azo group is produced as N2 gas. Then here one more hydrogen is there now out of two. One is combined with chlorine and one more is there. This hydrogen is attacked on this benzene nucleus. Thus we get here benzene. Thus here benzene diazonium chloride is reduced to benzene when reacted with here phosphoric acid in aqueous medium, and this phosphoric acid is oxidized to phosphorus acid, okay. And similarly here this benzene diazonium chloride is react with ethyl alcohol also. With which one? Ethyl alcohol, CH3 CH2OH. This is the ethyl alcohol. When it is react with each other, then here what happen? This hydrogen, this Cl removed as HCl, and N2 is produced as N2 gas, and here one hydrogen is attacked on this benzene nucleus. Thus we get here benzene. And here what is there? CH3 CHO, that is acetaldehyde or ethanol we get. Thus benzene diazonium chloride is reduced to benzene with ethyl alcohol, and ethyl alcohol is oxidized to ethanol. Thus in these two reactions, here N2Cl group is replaced by hydrogen atom, okay, because each carbon has two hydrogens here in benzene. Thus here this azo group can be replaced by hydrogen also, okay. Thus we can prepare chlorobenzene, bromobenzene, fluorobenzene, cyanobenzene and iodobenzene, okay, and phenol and benzene also, and nitrobenzene also we can prepare from benzene diazonium chloride by the replacement of diazo group, okay. These are the reactions involving displacement of diazo group, okay. Next, second type of reactions are reactions involving retention of diazo group. Reactions involving retention of diazo group. These are also known as coupling reactions. What are they? Coupling reactions. What are the coupling reactions? Here the reactions in which diazo group is retained, that is N2 group is retained, but X minus is replaced. Such reactions are called as coupling reactions, or reactions involving retention of a diazo group. In this one, first one is coupling with phenol. Here benzene diazonium chloride N2Cl. This is the benzene diazonium chloride is react with the phenol. Phenol is C6H5OH. This is the phenol. Then here one hydrogen is there now. Benzene diazonium chloride and phenol are react with each other in the presence of weak base, that is pH range is 9 to 10 range. Then what happen here? This HCl can be removed. Then this carbon is attacked on this nitrogen. Thus we get here which group? Here N double bond N C6H5, here OH, H4OH. Okay. So if OH is not there, then that is called as azobenzene. What is that? Azobenzene. That is called as azobenzene. But azo group is N double bond N. Okay. Then with respect to this azo group, this position is called as opposite position, that is para position. At para position OH is there. Hence this is called as para hydroxy. Para hydroxy azobenzene. It is present in orange color. Hence it is used as orange dye. Thus the products formed in the coupling reactions are colored compounds, thus used as dyes. Okay. Thus benzene diazonium chloride is react with phenol in weak base, that is pH range is 9 to 10. We get para hydroxy azobenzene. And the second reaction is here, coupling with aniline. Then take benzene diazonium chloride and Cl. Benzene diazonium chloride, which is react with phenol. Phenol completed now. This is the reaction with aniline, means C6H5NH2. Thus here a hydrogen is there now. This reaction takes place in the presence of acid. Because this is a base now, it takes place in the presence of acid. Phenol is a weak acid, hence it takes place in the presence of base. Like that you have to remember. Then HCl can remove. Then this carbon is form a bond with nitrogen. Thus we get here N double bond N, here NH2. Okay. That benzene diazonium chloride is react with aniline in the presence of weak acid. Then HCl can remove, that carbon forms a bond with nitrogen. Thus we get this compound. Now name of this compound. If this NH2 is not there, then what is the name of this compound? Azobenzene. This is called as azobenzene, and N double bond N group is called as azo group. Okay. Thus this position with respect to azo group is para position. At para position what is there here? Amine group is there. Hence name is para amino azobenzene. And it is also colored one. It is yellow in color, hence used as yellow dye. Okay. These are the coupling reactions of benzene diazonium chloride with phenol and aniline. Okay. In the first case we get para hydroxy azobenzene, that is orange colored compound, hence used as a orange dye. And para amino azobenzene obtained when benzene diazonium chloride is react with aniline. Then Here that compound is in yellow color, hence it is used as a yellow dye. Okay, these are the chemical properties of benzene diazonium salts. Okay, next one is importance of benzene diazonium salts. Next one, importance of benzene diazonium salts in organic synthesis or synthetic chemistry. Here this benzene diazonium halides or salts are very good intermediates. These are the very good intermediates, hence these play an important role in the synthesis of organic compounds. So benzene diazonium halides play an important role in the synthesis of organic compounds, because here it is a very good reactive intermediate. For the preparation of large number of organic compounds, like here chlorobenzene or bromobenzene or cyanobenzene or fluorobenzene or iodobenzene, nitrobenzene, okay, phenol, benzene, etc. Thus, this N2X group is easily replaced by Cl, Br, CnF, NO2, OH, etc. Hence, this benzene diazonium salts are very good reactive intermediates for the preparation of so many number of organic compounds. Okay, thus it plays an important role in the organic chemistry. Okay, so why it is very useful? Because here in this benzene diazonium salts, a best leaving group is present, that is here N2 group, azo group is present. So it can be easily removed from this compound. Then it can be replaced by these all halides or cyano group or monovalent atoms or groups. Thus it is very easy to prepare these all compounds. But direct halogenation or fluorination little bit difficult compare with this method. Okay, just by using this method quickly we can get the products. Okay, thus it is very useful reagent in the organic synthetic chemistry. Okay, this is the importance of benzene diazonium salts in organic synthetic chemistry. Okay, so this chapter is completed. Thank you. Here these are the important topics in this amines chapter. Okay, what is the first one? Hoffman bromamide degradation. So many times asked, repeatedly they asked. Okay, very most important. And diazotization, basic strength of aliphatic amines and aromatic amines and ammonia comparison. IUPAC names, especially tertiary amines they given, tertiary amines and secondary amines. They just read primary amines also. Then a carbyl amine reaction, Sandmeyer's reaction, Gabriel thalamide synthesis, reaction with the Hinsberg reagent and reaction with the nitrous acid, reduction of nitrobenzene into aniline. And next one is the electrophilic substitution reactions of aniline. Okay, and you can read remaining preparation methods also. But most important are Hoffman bromide degradation, next diazotization, basic strength, IUPAC names, carbyl amine reaction, Sandmeyer. Okay, these are the very most important. And here these also named reactions are most important. Then if you have time, you can read the remaining topics also. And what is the weightage of this chapter? 5 marks. Okay, 1 5 marks question will come. And in the final examination, question number 35. Okay, in 35 they will give 3 bits, 1 2 3 like this. Okay, total these 3 have 5 marks. Okay, based on this amines chapter. Okay, thank you.